Hey guys, this is Fran from Coolproyect.es producing this video for L'Expert Frigogeeks blog. In this video we start with the calculation of the thermal load in the cold room. The first load we are going to see is the transmission load. This is the heat flow through the walls, roof and floor of the room. Let's go for it. For starting the calculation, we need to gather the required information about the project. We need to set the different variables involved in this process. For example, the outdoor temperature and relative humidity. I have chosen the case of Seville here in Spain, where it's very hot in summer. I can certify that. On the other hand, we have the product features, room temperature and relative humidity. Our product is packaged chicken fillets. Room temperature is 0 degrees. Typically in cold room is 0 to 5 degrees. The room relative humidity is about 85%. Typical here is 85 to 90%. If the product is not packaged, we need to set 90%. Initial product temperature is 25 degrees in this case, and final product temperature is 0 degrees, just the room temperature. We have to check this information about the product, like specific heat above freezing, in the databases, for example in Azrai handbooks or in the software we have available in the market. Another factor is respiration load. In this case is chicken and respiration load is 0, but in the case of fruits and vegetables we'll have some respiration load. And for the packaging of the product we can use an enlargement factor of about 15%. Another thing to know is position and orientation. Usually cold rooms are inside a refrigerated area, as is the case, but we have to set the ground temperature. In this table, I offer you some simple formulas to modify outdoor temperature according to orientation. For example, we can estimate ground temperature as outdoor temperature plus 15 all divided by 2. Next, we have to fix the wall, roof and floor features. Normally we use polyurethane sandwich panel with thickness between 80 and 100 millimeters. You can optimize the thickness, we can do in another tutorial, but you won't be wrong with these values. We have the thermal conductivity of the panel and we use a convective heat transfer coefficient about 10 watts per square meter and Kelvin. This convective coefficient takes into account the effect of air velocity inside and outside the room. Regarding the floor, it's normally to use reinforced concrete floor and must be isolated typically with 50 mm expanded polystyrene panel. Concerning occupancy and illumination, we already told that in cold room we can ignore this factor. In relation to the evaporator, we had the frost resistances and fans which will produce heat inside the room. Finally, in this project we haven't considered other extra loads. Okay guys, let's start calculating the transmission thermal load. Here is the equation we have to use. First of all, we need to define the walls, roof and floor heat transfer coefficient. Normally, the coefficient is the same for the wall and the roof. Is this K, C, and we have Ks for the floor. These transfer coefficients include thermal conductivity and convective coefficient. We can see here the formula we are using. We have here inside convective heat transfer coefficient about 10. Here is the outside convective heat transfer coefficient is about 10 too. This K is insulation thermal conductivity. Here is the typical value for polyurethane. And E is the insulation thickness. In this case is 100 millimeters. We have to use this dimension in international unit system. It is in meters. This is the wall surface, and we have outdoor temperature 25 degrees and indoor temperature 0 degrees. We have to apply this formula for every wall and the roof separately, and we have to add these products for each wall and the roof. And separately we have the floor. For the floor we have our own heat transfer coefficient, this K sub S. This coefficient is similar to the coefficient for the wall, but it's a little bit different. We have this convective heat transfer coefficient inside, but there isn't any coefficient outside. And here we have to take into account different layers for the floor. First layer is the concrete floor. Here we have the thickness of the concrete floor, and here we have the thermal conductivity. And here we have the thickness of the polyurethane panel and the thermal conductivity for the panel. Here is the solution for this coefficient. And on the other hand, we have the floor surface. In this case is 18 square meters. The ground temperature is 26.95. We can calculate this, as we told before, from the outdoor temperature. In this case we have here outdoor temperature plus 15 all divided by 2. If we replace all the values we have calculated in this formula, we have this. Transmission thermal load is the product of different components. We have here K sub C. Here we have the addition of the different wall and roof surfaces. This is roof. These are 2 walls, and these are the other 2 walls surface. Here we have outdoor temperature and indoor temperature. Here we have K sub S for the floor. This is the floor surface 18, and this is the temperature difference between the floor and the inside of the room. The calculation of that gives us 1012 watts, and this is the solution for the transmission thermal load. As you can check, this is easy to calculate. For this calculation it's important to be organized, because it's very easy to make some mistakes adding the different surfaces and doing these products. I invite you to repeat this calculation in order to assimilate that better, and if you want, you can apply this equation for your own cold room. If you have any questions or some doubts about that, you can ask and write a comment here in the video, and I will answer you as soon as possible. I know there are some concepts like the origins of the root of this equation and the physical meaning, and if you want, we can do some new videos in the future to explain this heat equation, which is a mix between Fourier law and Newton law for the conduction and convection heat transfer. And we can explain more about this convective heat transfer coefficient. But I think with this equation and these values, you can calculate your transmission load without any problem. Okay folks, that was all for this video. I hope you took advantage of this. I'm looking forward to your comments, and I'll be glad to answer you. In the next video, we will address the calculation of the infiltration and ventilation load. I'll see you then. Bye!